All right, we're going to be transitioning these next couple lessons going from transformations, rigid motions, isometric transformations, into congruence. And we're going to be making our way into proving triangle congruence. And how do we know that two triangles are congruent? Well, the first way we know is by going from rigid motions. If we have rigid motions, we're going to have triangle congruence. That's what the next couple lessons are going to be about. So first thing here, we start off right with an example. The figure to the right represents a rotation of triangle ABC 80 degrees around vertex C. So the center of rotation is vertex C, and we started off with this. This is the pre-image, all right, and this is the image, and it rotated around. So if it rotated around 80 degrees, okay, name the triangle formed by the image of triangle ABC. Well, clearly it's, there's only one other triangle there, so that was pretty obvious. But what's tricky is the way you write it. You can't just write CFE, EFC. The order in which you write the letters is important. So see how it's ABC? Where did A go? Well, A went to E. So it's important to write E. So it says name the triangle formed. The triangle formed is triangle. So we have to start with E because A was the first thing we started with. So it's E. And then B rotates around to F. Okay, so it's F. And then C didn't rotate at all, right? It just stayed where it was because that was the center of rotation. So C rotates to C. So triangle ABC formed triangle EFC. The order of the letters is very important. Write the rotation in function notation. That's going to be something that's going to be new for us in this lesson. Now we did learn we did compositions. So before say it was a reflection of a rotation, you would do R and then a little O, R. We're going to write that now with parentheses. This will be written reflection of a rotation, like that. Okay, so you'll see that later in the lesson. But anyways, in this case, we only had one. We didn't have a composition. We just had one rotation. So we're going to call it R, right? And what comes after the R is the center, and the center was C. So it's R subscript C, and then comma the angle of rotation, which they said was 80. So R subscript C comma 80 degrees. That is the rotation in function notation. Okay? And name all corresponding sides and angles. I'm going to switch colors for that. So name all corresponding angles and sides. Corresponding is going from what you started with to what you ended with. So A, right, went to E. We already said that. So angle A corresponds with C. Okay? We already said that B went to F. So B corresponds to F. We'll just put an arrow. Arrow means corresponds. They match up, right? And then C corresponds to C. Wait. A went to E. I wrote C. Sorry. This should have been E. EFC. Just like we did here. EFC. ABC went to EFC in that order. Okay? So A corresponds to E. B corresponds to F. C corresponds to C. How about the sides? Okay, well, side AB after the rotation lands on FE. You could just go off of the letters. Again, AB, A corresponds with E, B corresponds with F. So A went to E, B went to F. So AB must go to EF. So AB must correspond to EF. You put little bar over those. AB goes to EF. AC goes to EC. Okay. AC goes to EC. Again, just a segment bar over top of those. And, of course, the short one, right, BC goes to FC. BC to FC. All right, so those are the corresponding sides. So very important to understand the corresponding sides and the corresponding angles. Now in example 2, we get ABCD is a square. They're telling you it's a square. And then it said triangle ABC is a reflection of triangle ADC across segment AC. So what happened is this is a reflection line. The diagonal is a reflection line, and that triangle can fold right on top of the other one. All right, and what they want us to do is complete the corresponding angles inside. So it's pretty easy. So if we did a reflection here, if we did the reflection, okay, this angle would go to that angle, right? I'm gonna do colors. This angle would go to this angle. This angle would go to that angle. Those are the corresponding angles. So BAC is this guy. BAC is this one here. That would match up with this one, okay, and that's going to be DAC, angle DAC. ABC would match up with ADC, angle ADC. BCA, the green one matches up with this green one, DCA, angle DCA. Okay, so hopefully you understand that. And then now the sides. How do the sides match up? Well, AB, that would reflect over to AD. See the reflection over that diagonal? So AB would go to AD. And then BC would go to DC. BC would go to DC. And then AC, and this is going to be something we're going to be talking about when we get into our congruence proofs. Very important. AC just stays where it is. So AC goes on to AC. That's interesting, isn't it? It's the exact same segment for both triangles. Okay, very important to understand this. So are the corresponding sides and angles congruent? Are these all congruent? Could I put a congruent sign in between there? Of course I could. A reflection, right? Because it's a reflection. So yes, because a reflection is a rigid motion. And here I'll say, are they congruent? Yes, the triangles would be congruent because all reflections, or you could say all rigid motions, keep the same size and shape. And that's what congruent means. So any rigid motion, reflection, rotation, translation, those are our rigid motions. Those are our isometries. They're called isometries, right? All of those, reflection, rotation, translation, they keep the same size and shape. Therefore, they're giving you that you keep congruence. Okay. Now down here, this is there's nothing to do. It's already done for us, but it's kind of a lot going on. I just want to explain what's going on here. Make sure we understand what's going on. So see this here? This is that function notation I was talking about earlier. And we're going to read this. It's a translation of a reflection of a rotation of triangle PQR. And again, we did compositions, right? This is the exact same thing as, see the parentheses there? You could put the little O, right? T, O, R, O, capital R, and then we would put, triangle PQR. This is the same thing as this. but instead of the little O symbol, the little midline O we talked about with compositions, now we're doing it with a parentheses. And the parentheses, it's function notation. Remember we did function notation? F of x equals 3x minus 4. We did that way back when we started transformations, right? So just like functions can be written in function notation, so can these, because these are just functions. All right, these rigid motions are just functions. So we say T of R, okay, and we write it that way. But again, it's backwards. It's backwards. So the first thing done was the rotation, then the reflection, then the translation. All right, so where did we start? I'm going to do this. I'm going to highlight it. We're going to color them in, okay? So we start with triangle PQR. Where are we at? PQR, right here. We start there. So that's number 1. This is number 1. All right? Then we work backwards. We work backwards, okay? And we do a rotation first. It rotated around point D. See that? It rotated around point D, 120 degrees. You can't tell that by looking at it, but it's given, right? They told you 120. It rotated 120 degrees, and it became this triangle. So I'm going to label that triangle, triangle number 2. Going backwards, right? Triangle number 2. Continue to go backwards, okay? It reflected over line EF. Here's EF. It reflected over that. What happens when you reflect over that line? It goes to this triangle. There's triangle number 3. Triangle number 3. Then what happened? You keep going backwards. You're going to get triangle 4 when you do the translation finally. And of course, translation is the vector. It slid this way to triangle number 4. So first a rotation, then a reflection, then a translation. Rotate, flip, slide. Boom, boom, boom. All rigid motions though, right? So what we can tell is the original triangle is going to be the same size and shape as the final triangle. This is how you write it in function notation, and this is what they're going to have you be doing in the lesson today. All right. So example 3. I don't have it here. We're going to do this in class, actually. Okay, so we're going to do example 3 in class together because it needs a compass and a straight edge. But what we're going to do is part B together right now because we don't need the construction. We might even skip the construction. But what I want to make sure we do is do the function notation. Okay, so part B wants us to use function notation just like what we did back here. Okay, right here, this is what they're talking about when they say function notation. This description right here. So it says, this is what we're describing here. So first reflect ABCD over line M. Reflect over line M. But again, it's got to go backwards, right? Then translate. So let's write this out. It's reflect, then translate, then reflect again. So it's reflect over M, then translate, then reflect over N. That's what we're doing here. So now, again, function notation is backwards, so we're gonna go with the last thing. Actually, is going to be written first, so we're going to start with that. All right, so we're going to reflect. We're going to say reflection over line N of parentheses translation by vector V. So we put a little subscript V with a little arrow over it, right? Vector V of reflection in line M, lowercase r, subscript M, of triangle what? Oh, I'm sorry, rectangle, not triangle. Rectangle of rectangle ABCD. And then we go close parenthesis, close parenthesis. You got to close parentheses for each one. Close the parenthesis for the reflection, close the parenthesis for the translation, close the parenthesis for the other reflection. Okay? That's function notation. Composition of transformations written in function notation. This is big boy and big girl math, okay? If you don't get this, it's okay. We're going to practice it. You're going to do 3 or 4 of them in class tomorrow, all right? Complete the following sentences. Rectangle ABCD is blanked to rectangle EFGH. Well, after you do a sequence of rigid motions, they're going to be the same size and shape. So that's called congruent. They are congruent because rigid motions map point A to point E, point B to point F, point C to point G, point D to point H. Rigid motions map segment onto congruent segments and angles onto congruent angles. That's the congruent symbol. Blah, blah, blah. Okay, last one, example 4. And this is going to set us up for what you're actually going to be doing in class. So, look what happened here. ABC is the first one, right? So you could see it was reflected over DE. Reflected over DE, and it goes here. So this is 1, this is 2, right? Then it was translated to 3, and then it was rotated. It was rotated. See that? And that's 4. So it's, what is this here? Let's label what this is right here. This is a little reflection, DE, reflection over DE. This is a translation of across B prime to B double prime, B prime, B double prime. Translation from B prime to B double prime. And then what's this? This is a rotation of some angle. We don't know, whatever the angle is. But what's the center? A triple prime. So we're just going to put A triple prime, and then we'll make, what does this angle look like? I don't know. We could measure it. Let's just say 80. We're just making it up, okay? All right, so sequence of rigid motion. So what happened? The sequence is reflection, then translation, then rotation. That was the sequence of rigid motions. We just did it. Boom, boom, boom. All right? Composition and function notation, got to go backwards. So it's a reflection. I'm sorry, not a reflection. A rotation. So we're going to write R, rotation, A, triple prime, of, parentheses, what was next? The translation, B prime, B double prime, of, reflection, DE, of triangle ABC. So again, if you were to do this, oh wait, we need 3 parentheses. I'm out of room. 3 parentheses. Can I squeeze them in? There's 3 parentheses there, guys. Parenthesis, parenthesis, parenthesis. Okay. Now, if you were to do this, you would do the reflection DE first, then you would do the translation, then you would do the rotation. That's exactly what happened. Start with that. Reflection first, went to there. Translation, went to here. Rotation, went to here. Okay, so it's the order that matters. Sequence of corresponding sides. AB. Let me just erase these. Okay, so AB corresponds to what? AB corresponds to A triple prime, B triple prime. It's pretty easy, right? BC corresponds to B triple prime, C triple prime. And AC corresponds to A triple prime, C triple prime. All right? And sequence of corresponding angles, obviously angle A corresponds to A triple prime. B corresponds to B triple prime. And C corresponds to C triple prime. Pretty simple. And what's our triangle congruent statement? Triangle ABC is congruent to triangle A triple prime, B triple prime, C triple prime. That's what happened in the end. Why? Because it's all rigid motions. Sequences of rigid, it's a sequence of rigid motions or isometries, whatever you want to call them. All right? See you in class tomorrow.